Hello, folks, and welcome back to the Routing Loop. We're starting a new year. I know that we've had a reInvent recap last week, but I'm going to pretend that this is the first one for the year. And we're starting our series on all of the Chalk Talks that happened at reInvent past year that got really good scores. The audiences really, really liked it. And for all of those here who didn't get a chance to see it or to take advantage of asking questions, we've brought in Vinny and Jonathan to talk about Amazon CloudFront and origin management for multi-region applications. So to kind of kick things off, hey, Ken, I see you there. And hey, Ari, it's good to see you guys again. Let's just introduce our folks here who are going to be leading us through this. So I'm going to start with Vinny, because Vinny, you're on the top. Tell us who you are, what you do for Amazon, and all that fun stuff.
Thanks, Jamie. Glad to be here. Great to see everyone. My full name is Vinicius Pedroni, but everybody calls me Vini, so that's easier for everybody. This is going to be year 10 at AWS. I've joined back in our premium support side in Dublin, where ever since I joined, I'm supporting CloudFront. So it's just great to be here. Right now, I'm a senior solutions architect within our US enterprise space, supporting some travel and hospitality customers. So great to be here and great to talk about CloudFront today.
Awesome. Vinny, thank you. Jonathan, why don't you tell us a little bit about yourself?
Yeah, thanks, everybody. Good to see everybody. My name's Jonathan Woods. I am a solutions architect in the SMB space in the United States. I've been here for about 4 years, started off in professional services, made the switch. And Vinny and I are both kind of in a technical field community that focuses on kind of what we're going to talk about today. So excited to be here. Thanks for having us.
Nice. And just for those folks who know technical field communities, such as I belong into the networking one, Vinny and Jonathan belong to one of our edge ones. These are basically internal groups of like-minded individuals, SAs and TAMs and all that, who have a level of expertise that can be called upon from everyone else in the field. So when any of you have a problem that is for anything edge, right, Jonathan or Vinny, it's a good chance that they might be there to help you out. If that request goes to them. So it's even better because they have that upscaled or upskilled expertise to be able to answer these questions. So cool. So talk to me a little bit, guys, about CloudFront and CloudFront Origin. What are we going to talk about today? What are we going to learn? I also understand that we're going to be doing demos and showing the console and all that good stuff too.
Yeah. So we're going to be talking a little bit about CloudFront with multi-region applications. So how do you manage it as you're expanding, as you're growing? We all know that there's been a lot of just how do we manage our front across multiple endpoints, right? Our company's growing. How do we do that? So we're going to hear talk today a little bit about CloudFront and how we can do that with multi-region management.
Cool. And then just to level set everyone, tell us a little bit about CloudFront and how it's differentiated from, say, other CDNs.
Yeah, Vinny, I'm going to throw it over to you for the 10-year expertise here.
No, absolutely, and it's a great question, Jamie. So with CloudFront, we really aim for it to be your real entry point into any application you're thinking about publicizing it. Not just from normally when we're talking about CDNs, we tend to just go straight in thinking about caching and performance, which it obviously is one of the main things that you want to achieve with the CDN. But the level of integration that CloudFront has with other services within the AWS ecosystem, such as the Web Application Firewall and Shield Advanced and recent additions that make it so it's not just the front end from a performance standpoint, but also from a scalability, security, and availability standpoint as well. CloudFront will have features and feature sets that will help you, any customers that have these public applications, deliver them securely, scalable, and with many other additions. One of the more recent ones, private origins, right, which has been like a very big topic ever since I joined AWS. Protecting your origin from all those risks that are out there. So there's just a varied suite of features within CloudFront that go way beyond just caching and performance, which again is very important. But everything else that CloudFront does for you, when we're going to talk about some of those today. So
cool. Yeah, I could just sneakily say that one of my favorite things about CloudFront, and it's in a way of us cheating at AWS, because we do control all of the backbone fiber, is we bring our backbone directly to CloudFront. So minimizing that distance over the internet, or what we like to call internet weather, where how responses and requests are not at the same speed, because who knows what happens with
absolutely. And also
we minimize that, which is
awesome. Absolutely. Yeah. And with that, Jamie, it also comes, we're going to talk a little bit about some of those settings you have at CloudFront to control a little bit of how that networking goes.
Perfect.
So it's really, awesome to see how the service has been evolving ever since, with some very cool additions lately. That's another great one.
Cool. So why don't you guys kick us off and take us on our CloudFront journey?
Yeah. Let's jump in. We've got a couple slides. We'll kind of run through, just kind of level set with everybody, and then we'll jump into the console and show some demos and some back-end architecture.
We love demos. And folks in the chat, please bring up your questions. If not, I'm going to ask some questions on your. And yes, Erie, we are doing exclusive content for Chalk Talk. So if you did miss them, this whole series, I think it's going to be next couple of months. We're going to be recapping these, and of course, Vinny and Jonathan did a really good job, so they get to be first. So take it away, guys.
Yeah. So kind of the starting point, and we kind of alluded to this, is from our conversations Vinny and I have with customers, either where you're a large enterprise customer or you're just kind of starting off. These are the reasons behind, like, the whys that we hear from going multi-region, or the pain or joy of going multi-region. Maybe like, you've got some geographical redundancy you need. You've got an application where you need to make sure that you don't have regional failures. My application for my business needs to be able to be accessible, even if one region goes down in a major outage that's happening. We want that business continuity, even in that kind of that redundancy from that geographical space. Or like we hear all the time from customers, like, hey, we've got GDPR and data sovereignty laws that require the citizen data to remain in specific geographical boundaries. That's why people go multi-region, right? Like we've traditionally been a US-based company. We're expanding into maybe other places of the world, and there's other rules and laws that we've got to abide by. A lot of customers that we talk to are just having disaster recovery mandate conversations. Like, how do we make sure that our recovery time in our RTO and RPO, those are met? Whether it's like, hey, I've got insurance policies that I got to make sure I keep, or we've got some board level risk management conversations that we're having, and customer SLAs, right? Where we want to make sure that we're recovering as quickly as we can. And then the third or fourth reason, really, it's the best reason is like, we're expanding. Our company started off with X amount of users, and we've tripled, quadrupled that over the last couple of years. And we want to make sure that we are set up to either provide our application for our customers quickly, or we're providing better cache ratios, better failovers, better all those mechanisms that CloudFront has to offer that we kind of alluded to earlier. That's kind of the starting point that we hear from a lot of customers. So we've got a question. We'll kind of throw it on the slide. It's kind of in the chat as well, that maybe you can think through and maybe ask yourselves, or put in the chat. We'd love to hear from you. Like, what are some of the key considerations if you were going multi-region, or maybe you're going multi-region right now? Like, hey, my business is wanting to go multi-region. We've had some of these conversations. These are the key considerations that we have as a business, right? Maybe it's some of those things that we just talked about earlier. Like, these are some of the reasons, but we have some real key considerations about uptime, or some real key considerations on data application latency. Whatever those is, we'd love to hear kind of what some of the things you're thinking about maybe within your company, the conversations you're having. But the challenges we hear, okay, so let's say you've gone multi-region, you're thinking about going multi-region. And then it becomes a question of, all right, so I'm having challenges. Like, okay, I decided to go multi-region. That's fantastic. But it's not just necessarily deploying about more things. I've got to figure out, all right, what's going to be my DNS strategy? How do I make sure that if I'm going multi-region, if I am in Tennessee, where I am today, and I want to hit your application, where am I going to be routed to versus somebody in Dublin? How are they going to get to your application? What's the strategy to get to those origins? How do I handle sessions, right? If I've got sessions on my phone, sessions on my desktop, sessions on my iPad, how is that session management happening? Or just some of the latency optimization that we said. Again, the same example. I'm here in Tennessee. Somebody is in Dublin trying to hit your site. What's the latency issues or challenges you're going to face, when going multi-region? Or even just as simple as a caching strategy. How do we make sure that some of our caching is done at an optimal way that I can reduce backend requests for my origin? The application is going to be going quicker, not going to have to be paying as much, hopefully. These are all kind of the challenges that we hear. And so, spoiler alert, the answer is going to be CloudFront for this. Surprise, surprise. But that's kind of what we want to focus on today. I'm going to throw it to Vinny to kind of maybe walk us through a little bit of that.
Yeah. Thanks, Jonathan. And we've talked a little bit about this when Jamie asked the question about CloudFront, but level setting a little bit, what we have here on the screen is essentially the lay of the land, right? Where things stand right now. And not too long ago, maybe 2-3 years ago, I remember helping the service team writing a blog post where we were celebrating, I think at that moment, it was our POP number 400. So since then, there has been almost doubling the size. And that's just to give a perspective of how large the current CloudFront footprint is. And the main thing that this offers you, again, from Jamie's point earlier, it's really about the performance, that getting into the POP as early as possible from a user perspective is going to get you with that backbone connecting back to your origins, right? So
talk about POPs, Vinny. Tell me about POPs. What are, like you mentioned POPs. Can you explain that a little bit?
Yeah.
What's like in anatomy? What's in in a POP?
Yeah. So a POP is a point of presence, or commonly also referred to as an edge location, right? And that's essentially the first layer where any request to a application that's hosted on CloudFront is going to land on. So this is where our client, or within the CloudFront realm, we also refer to them as viewers. That's where they connect to. That's where they establish a TCP connection. That's where TLS negotiations are done. That's where cookies and maybe query strings are validated from a CloudFront perspective. That's also where something that we're going to talk later on, CloudFront functions. That's also where CloudFront functions run. And within the anatomy of a POP, it has multiple layers. So those multiple layers within the CloudFront edge location do all these different features or services that I was just talking about, all the way through having the edge location communicating back to what we call a regional edge cache. And now I'm talking a little bit more broadly about CloudFront architecture. So essentially, a group of POPs or edge locations, they are mapped to one of our 13 or 14 regional edge caches. And those regional edge caches, they sit in a region, right? So if you take like the East Coast of the US as an example, they are going to mostly use the US East 1 region as a regional edge cache. POPs in the West are going to use, a regional edge cache in the West. Same for Europe, same for APAC. And those have layers within them that execute different functions from a CloudFront perspective. So some of those layers are responsible for keeping connectivity open with the origin and reusing TCP connections. Others are doing compression. Other layers are actually triggering Lambda functions. So there's just a broad, term, and I know I kind of went a little bit further than the POP question, but a POP is really just the place where the request lands for the first time, and that's where CloudFront initiates its work of defining which distribution, what is the behavior, do I have this cached? If it's cached, where should I get it? And then either sends the response back to the user, or goes to the origin to retrieve that origin. And right now, over 750 POPs, over 1,100 embedded POPs. Those are POPs that live within telecoms, and there's a different process for enabling them if that's something we want to use on our distribution, let alone all the things. One very common reason, Jamie, I was just thinking about your question earlier. Another very common reason that customers look at CloudFront is also from a cost perspective. Right. We know DTO starts to get expensive, and it's a common way for customers to alleviate that, or when customers are coming from other CDNs, that's also a normally very interesting addition that they get besides everything else that CloudFront offers. So just at a high level, talking about CloudFront, so that everyone gets situated.
Let me connect just to connect a couple more dots. So you mentioned that we have 750 plus POPs, right? This is where CloudFront's distributions are copied around the globe.
Correct.
When a customer makes one of my customers, say if I have a CloudFront distribution, makes a request, what sends it to which POP? What's the mechanism that decides where it goes? What are some of the things that I can think about for CloudFront to say, hey, this is how it's accelerating my workload?
Yeah, there's multiple steps in that process, Jamie. So the most common way that CloudFront is going to decide on where your request is going to go to is by looking at your DNS request to resolve that CloudFront domain name and the resolver that it comes from. So essentially on the back end, our CloudFront architecture has a DNS routing logic, which decides, okay, this person, physically speaking, maybe Vinny is in a location that has a close edge location to him, but networkly, if that's even a word, technically speaking, it is now. Latency wise, it may be wiser for Vinny's request to land on a different POP, right? And that's how CloudFront decides. There's also a portion of Anycast that plays a picture into this, but initially that's how a request lands on CloudFront. So essentially, for those who are a little bit more familiar, when you create a CloudFront distribution, Jamie, to your point, you get your CloudFront domain name. And the way most customers configure their CloudFront distributions is they have an alias with their own DNS that points to the CloudFront domain name. And through that resolution, that will end up hitting the CloudFront resolver DNS servers. And those DNS servers are going to define, okay, this is the resolver that this request is coming from. So for this network here, it's better to go to this POP. And it's going to send the IPs for the POP that we define to be best for customers. Within CloudFront, there's a few ways, or one main way in which you can control. That's more from a pricing standpoint, which is you can choose if you're just going to use, say, North America as an example, North America and Europe edge locations, or if you want to scope your distribution to be able to use POPs around the world. And that's more from a pricing standpoint than actually, routing standpoint.
Dominic has a follow-up question kind of along that vein. Is there any way to skip or avoid the closest POP location in case there's like a performance issue or it's misbehaving? Do you have any kind of control over that or not?
Not really. That would be up to the service team. If they like, I'll give an example. Like if we think that we need to do a maintenance on a POP, they're going to take that POP out and you're not going to get requests there anymore. But from a client or a customer's perspective, there's really no way for you to control, practically control which POP it's going to land on. That's not something that CloudFront offers right now.
Got it. And then Tech, I see your question. Tech is asking the age-old question, CloudFront versus Global Accelerator. Don't worry, we'll get that into that a little bit later after these. I am a proponent for both. I love both of them, and I've handled this question quite a bit, as well as Jonathan and Vinny. So we'll be happy to address that, but we're going to address that a little bit later. And then again, just as a blanket conversation, when you ask, like, when are you going to enable this feature? Unfortunately, we're not allowed to talk about any roadmap items or features because I sit with the PMs. They'll just pretty much take me out, and then you'll never see me on the Twitch show again. So we can't discuss those, but please, if you do have those questions, get PFRs in, talk to your account team. You can ask for myself, Vinny, or Jonathan to actually address some of those concerns in a private private manner, happy to do so. They know how to get a hold of us. So I just want to make sure I put the blanket out. I'm not ignoring the chats that are coming in. It's just that some of the questions we can't answer. So I'm sorry, guys. Go ahead.
Cool. And getting to a little bit more of what we how CloudFront can help from the challenges that Jonathan was talking about earlier, right? And in most situations, when we get requests from account teams to talk to customers about CloudFront and multi-region and resiliency and availability as a broad topic, there are two things that those customers are normally looking for. One is from a routing perspective, how can they ramp up what they're doing right now? So how can they become smarter, or how can we more appropriately route user requests to the appropriate endpoints or content behind our that we may have multiple origins sitting in multiple regions, serving different content, serving different geographical locations. So that's one topic. The second topic is really availability. What can I do to improve how available my application is, and what can I do to minimize as much as possible the exposure of potential failures? Maybe it's not a full-blown disaster. Maybe it's just a transient failure that you're experiencing, that the application is experiencing, that you want to make sure the users are not being exposed to, right? So those are the two things that come to the picture. And as Jonathan mentioned on the chat, feel free to talk to us about how you could potentially be addressing those. But what you see on the screen here is a very simple architecture of one of the CloudFront features that can really help you, upgrade your posture in terms of availability. I was having a conversation with a customer, maybe a month or two ago, and they were really looking for how could they minimize as much as possible any failures to be exposed to their users. And they were both talking from a failover perspective and how fast could they fail over, right? And one of the features that we ended up talking about, because the conversation just naturally went there, was something that we call origin failover or origin group failover within CloudFront. So for those who are not that familiar with CloudFront, I'm just going to lay out some of the foundational building blocks of CloudFront just to situate everybody. When you have your distribution, there are two main constructs that you're going to have to build on your CloudFront distribution. The first one is what we call a behavior, and the second one is what we call an origin, or the origin setup, right? So the behavior is going to define how CloudFront is going to route a request for the most basic request, how it's going to route, how it's going to treat, how it's going to cache that request. And the behavior is defined by the URI path for that request. So let's say /static/image1.jpg hits S3 as an origin, right? As simple as that. That's the basic behavior configuration. The other basic construct is the origin configuration as well. And that defines what is the DNS name that we're going to be using to hit our origin. Is this an S3? Is this a custom origin sitting somewhere else? Is this, are we using a custom port to talk to that origin? So those are the two most basic constructs, right? And until origin group failovers was introduced, the way it works is very simple. You have a behavior, you define the origin, that's it. As simple as that. When you have, with origin groups addition, that adds a second layer of failover capability from a CloudFront perspective. And the way it works is you are going to define those constructs within the CloudFront distribution. So you're going to essentially create two separate origins. From a CloudFront perspective, CloudFront initially will think, okay, these are two different origins, separate origins. And then you're going to create a group. So you're going to group those two origins together, and we're going to say which one is primary and which one is secondary. And based on that, CloudFront will react based on how the primary origin responds. So this is a very failover type configuration. It's not going to do, active or anything of that sort. It's going to be a primary, secondary, or primary passive, whichever way we want to call it. But there are some interesting aspects to this. The first one is you can granularly say which types of HTTP errors you want failover to react to. So you could go within the origin group failover configuration, and you could say, for anything 5x, so 502s, 504s, 500s, I want you to use the origin group failover. And when you do that, what will happen is, so looking at the screen here, our green path is our primary. So let's imagine for a second that CloudFront receives a request, sends that to the origin, and the origin is having an issue. I don't know, a 503, a 502, whatever. CloudFront will receive that error. If we're not using group failover, origin group failover, that error is simply sent back to the user, right? Unless we have an error page or some more customization, the error is just sent back to the user. Hey, user, here's your 503. If we have the origin group failover set up, CloudFront will immediately react to that failure, and it's going to immediately send back to the second origin, right? What that will create is essentially a brand new request to a second origin. Of course, it's going to go to the same URI path, the same characteristics of that request will go to the secondary region. And the secondary region, if it's up, it's working fine, it has the content, it's going to reply with the 200 and then send that, and then CloudFront will either cache or do whatever it needs to do with that and respond to the user. So here we've just created an experience where even though maybe we had a code that did not run properly, or we had a transient 500, I think a lot of people here probably have seen like some transient S3 errors with 503s and things like that. This is very good for that type of use case where we're also trying to minimize as much as possible those temporary failures that our application may be experiencing. And of course, on a larger scale, also take care of potential worse disasters, because that will react immediately to that failure. Good things to keep in mind here. This does not keep track of health. So for those who are familiar with Route 53 and health checks, CloudFront does not do that. Meaning, even though your primary could be out for 15, 20, 30 minutes, every single request that CloudFront receives, it will keep sending that to the primary, getting the error, and sending to the secondary. Right? So it's what we call normally a request level failover. So it will react based on the request. And also another very good thing to keep in mind is this works mostly for, this works for get, heads, and options. So it's more on a read perspective.
So we have a related question from Ken. What is the fastest failover? Primary to secondary origin failover or Route 53 traffic failover for the origin DNS name?
Well, Ken, we'll send you your $5 because that's a great question. We paid you to say that question, so appreciate it.
Thank you so much for that question.
Because it leads right into our next idea.
And we're going to actually see that on the demo. So where does this conversations normally take us? It take us to using both, right? They're not exclusive. You can use them together. You can pair them together. And we're going to show you that. But in that scenario that we have here on the screen, we're using origin failover and we're using also the Route 53 capabilities, right? Because with origin failover, the main thing that we want to do is failover as fast as possible, but also be careful with how we failover, because maybe it's just a transient failure and we don't need to trigger a full-blown failover to a secondary region, right? Maybe it's a transient, we just need to take care of that specific request, have our user not experience any failures, and move on. Our primaries is still good, right? So the setup that we end up seeing with customers adopting when they need like a more complex setup is CloudFront origin failover paired with Route 53. The example that we're going to see on the demo on the next slide and that we're going to show you on the console is the one that you're seeing here on the screen. And we just wanted to diagram it so it would, easier to understand. From a CloudFront perspective, the origin group will have two origins. The first, or the primary origins, is going to be the Route 53 failover route. And CloudFront will have a second origin, which just simply goes straight to the secondary, right? And then what that will give us is the minute or the second that CloudFront sees a problem on a request, gets that 500 we were talking about, it will react and send the request to the secondary. However, if that failure is sustained for, like, say, minutes, then Route 53 will do its work. It will trigger the health checks. Depending on the logic that we have. Here, we're just using a simple failover policy as an example. But let's say, like 3 health checks went by, we declared the primary failed. Now Route 53 will take over, and it will start replying back to CloudFront, hey, CloudFront, here's your new primary. And then CloudFront will stop doing its failover mechanism because CloudFront now believes that the primary is back up and running, right? And what that gives us is you get the best benefit of CloudFront, which is immediate fast failover, because it's going to react based on an HTTP error. But it also gives you the more control that Route 53 offers you, because now you have health checks built in, and you can do all sorts of things with health checks. It could be like a simple HTTP request, or it could be like a more complex with CloudWatch metrics and things like that. So that's where customers ended up going. They kind of use both, but normally customers are not fully aware of origin group failover, how it works, and things like that.
Well,
and that's what we want. Yeah,
I was gonna say too, like nitrate or nitrat. I don't know. You had a great question too. If we can pull that up, you asked, like, can you control an origin failover timeout request to move to a secondary? Which, again, I'll give you your $5 too, because that directly goes to our next what we wanted to talk about. But Vinny, tell them about, like, some of the additional settings. The options they have.
Also, to Jamie's early question on the networking side, right? What you're seeing here on the screen are settings that are valid for custom origins. So things that are not S3, as an example, right? So by default, these are the default settings you're seeing on the screen. And when you set up an origin like that, you're going to have those settings to be available to you. So by default, CloudFront does 3 connection attempts. It timeouts after 10 seconds, and it waits for a response for up to 30 seconds. The reason why we just wanted to mention that is because that can influence how fast it can fail over. So if you want to do a quick test on CloudFront, stand up CloudFront, stand up an Apache server on EC2, block the port, and you're going to see this behavior here, and run a curl through CloudFront. You're going to see this behavior here. It's going to fail. It's going to fail after 30 seconds because it's going to try 3 times, and it's not listening on anything from the origin. TCP negotiation didn't work, and it's essentially going to fail. And this is important because if CloudFront is absolutely not capable of establishing a connection to the origin in the first place, that may influence how fast we're able to fail over. So I know,
let's show them what it looks like. Yeah.
You can kick off, Jonathan, but really quick, just explaining what we're seeing here. First URL is CloudFront plus Route 53 only, no origin group failover. Second URL is origin group plus Route 53, right? So you can see here that the minute we cause an issue on our primary, which is sitting within US East 1, our second URL simply kept going, right? And again, very simple task. We're just running a loop of GET requests against a specific URI. But this is how fast it works, right? I shouldn't even say it's fast. Like, it's immediate, essentially.
Yeah.
Because again, the minute that CloudFront sent the request to the origin, the origin responded with a 502. I think this was a 502. Yeah, 502 set the screen. A 502, CloudFront reacted and it started going to the origin. And only now, Route 53 is kind of picking it up, detecting the failure on the primary, and shifting the traffic to the secondary, right? And we're going to see a back and forth here. That's mostly because we have DNS TTLs, caching, that type of configuration also at play here that could influence. But from a CloudFront perspective, using both, we're good, right? It kept going, it did not stop, and I think we're going to see stability within the first URL in around requests 110, 115 or so, or something like that. I think we're getting close to that. But this is a very simple test. We just wanted to show you how the two react. And URL 2 by now, Route 53 has failed over. Now Route 53 is deeming USSist 2 as primary. So if we were to look at behind the scenes, CloudFront has stopped even doing the failover at this point because it's just going to the primary. So very simple, again, not anything rocket science here, just trying to exemplify the features that we were just talking about. I can also show the console.
Yeah,
I think that would be cool. Yeah. So I don't know if people can see my. Okay, I think you can see, right? Okay. So for those who are not that familiar, I'm just on the CloudFront console here. I have my distribution, and let me take this to the side. Here are the two main constructs that I spoke about earlier: behaviors and origins, right? So within my origins, you're going to see here, I have my individual origins. So I have my origin name called Route 53 failover origin. This is my primer. This is the failover record, right? So I'm going to show you Route 53, but these are my two records within Route 53 that compose my failover policy. And I have a secondary, right? And this is just a straight up direct endpoint to only my secondary. So here I'm just using a simple A routing. I'm not doing anything fancy. And then at the bottom, I have my origin groups, right? Where if I hit edit here and I show you what that looks like, again, very simple. This is my primary and this is my secondary. Give it a name. And here is where I define the failover criteria, which is what are the errors that I can set up CloudFront to react to, right? And that's the most basic setup that we can have. And then when I want to use that, I go to my behavior, and I'm going to show you my origin group failover here, which is the only change, the only difference from the regular constructs is that instead of pointing to a single origin, I'm now pointing to the origin group, and that's it. That's all we got to do. You're going to see that once you set that up, I'm not going to be able to do get post and puts anymore. That's because origin group failover does not support post and puts. But again, most customers, they differentiate those on their behaviors. So they normally have a behavior when they need to do uploads that go through CloudFront. They normally have separate behaviors for that. So that's from a CloudFront perspective, what we have set up. Now, let me quickly show you what it looks like from a Route 53 perspective. This is the DNS name I was using it. So if you look at my origin group domain name, right, which is, again, the one that's set up on my CloudFront, I have a primary and a secondary, and that's simply pointing to my ALBs, right? And I have an ALB in East 1 and an ALB in West 2, which have an EC2 running Apache on the backend. And when we tested, right, when we tested, the first URL, which was not using origin groups, was following this behavior. And the URL that had both the origin group and the Route 53 was going to this one here. So even within the same CloudFront distribution, we are able to mix and match. So maybe I'm only capable of doing this from an S3 perspective. I'm using replication. That's a very common use case. Customers can do that. Or you want to do that everywhere, right? That you can possibly use origin. Of course, you're going to have to keep your origins in sync. There's all that has to be considered. But the reaction to the failure is so fast that most customers do not even realize that something happened on the back end, right? And that's as simple as the setup that we have here is. We can make it more complex, but it's this simple to set this up. It's not anything, rocket science, as I mentioned, but simple enough that can get you started very quickly. And again, it's only reacting to the origin response. It's not really taking, going and doing health checks and things like that. And I know we only have 20 minutes. I'm so sorry, Jonathan. I get excited when I talk about these things.
Yeah, so let's jump back to performance. So no, this is good. This is good.
Got a question from X-Ray. Is there a preferred maximum number of origin group members?
Right now, you can only do 2. So you can only do your primary and secondary within an origin group.
Yeah, good question. So to kind of play off what Vinny was talking about, what we talked about was really like an active failover, active passive perspective where, hey, I've got an issue in my primary region and my original origin's having issues and I need to fail over fast, right? So CloudFront origin, the origin failover group is going to be fantastic for that. But we have a lot of customers as well, which you may be one of them, that's sitting there saying, all right, so I don't need the failover, I need the active, right? Or I've got some criteria for my application where 80% is going to be going to my primary, and then I've got a small percentage that may be going to my other failover or my secondary, right? So USOS2 maybe in this case from the diagram. And kind of to go back even to the question that was asked earlier is like, what do we use here? Do we use something like potentially Global Accelerator? Do we use something like CloudFront? And if you're trying to boil it down, and Jamie, I'd even pass to you. You said you like answering this question where you can think of Global Accelerator really just from the perspective of being a smart network router that accelerates the traffic. You get 2 static IPs that are at the edge location worldwide. So if my origin is in this case like an EC2, I've got 2 static IP addresses that I have the ability to configure dials or endpoint weights to determine where do I want my traffic to go. So you could use Global Accelerator in this case, say, hey, I'm going to use majority of the endpoint needs to host this traffic for 80% and then maybe another 20% for my West region origin. But CloudFront has some differentiating features that come into play that you don't get with Global Accelerator. But I want to, Jamie, I'm curious kind of from your perspective too. You talked about this.
I look at it, the way I look at it is like this. The most common thing folks like to say is, layer 7 CloudFront, layer 4 Global Accelerator. It's the most common answer. But there's a little more nuance in that. In Global Accelerator, if you need to have more finite control over your routing of where your traffic goes, because remember with the origins, or the endpoints, as they call it in Global Accelerator, you can be very particular of how much one endpoint gets traffic versus another. There's a lot of knobs and dials on that, right? And that's basically for workloads that are routing dependent, networking routing dependent. And when I look at CloudFront is request dependent, is what I'm saying. When you need to get a request back from a website, an application, a page, CloudFront is best at doing this because of its caching ability, because of its fact that of the extra features on it for routing, changing your request with the Lambda at edge. When I'm looking at request-based applications, that's where I go and I look for CloudFront. So that's
perfect, 100%. And again, you kind of led into where we want to go next, where there's two main reasons that CloudFront has advantages or just differentiating factors over Global Accelerator. Now, again, you may be thinking, all right, Global Accelerator meets exactly what I need with what Jamie described, and that's what I'm going to go with for my multi-region application. Fantastic, right? I'm happy for you. That is exactly what we want if you can differentiate between the two and determine what's best. But if you're needing kind of what Jamie mentioned, maybe I got some advanced routing capabilities that aren't as easy to identify with just a simple weight of saying, again, my common example of 80 and 20%, right? So you've got a couple tools in the CloudFront toolbox where you can do some compute at the edge. So you've got things like CloudFront functions or Lambda at edge. where you can see they run or can run at different places upon the request coming in. So if you need to process code quicker, you can do that at the edge, which would do an option like with CloudFront functions, which is a lightweight JavaScript function. It runs at the edge locations. It's sub-millisecond execution on every request. And this is really more ideal for high scale operations like URL rewrites, header manipulation, or maybe even like a request validation at a really, really low cost. Lambda Edge is a little bit more bulkier. You can do Node.js or Python. They're running at the regional edge locations, and you kind of have access to the full AWS Lambda runtime. You can do external network calls, longer execution times, because like up to 30 seconds. And it's more suitable for those complex logic like A/B testing for maybe some external APIs, maybe some dynamic content generation, different authentication flows. The cost is a little bit higher. And from a latency perspective, they're both very, very low, but it's a little bit higher than the CloudFront functions. And obviously you can run it at different requests. But you don't get this with Global Accelerator. And maybe you have some functionality that you need to be able to do at the edge to be quickly change between different origins. You have that availability with kind of this compute option at the edge. And so what you get, oh, here we got a question.
We got another point too.
Yeah, this is great.
Timeout. That's a great point. CloudFront is 60 seconds hard. Global Accelerator, it not just the ALB, but it'll use the timeout of its endpoint. So ALB or NLB or the IP. So if you need to be very, very judicious, IP. But again, that's a really good call out.
Yeah, good call out. So let's kind of go through a scenario quickly where you've got an origin or a couple of origins, and you're thinking to yourself, okay, this is very easy. You can change or modify which origin you want to hit based off a CloudFront function, right? The pattern comes in or request comes in, and you have a repeatable pattern that you can differentiate between. I want to go to origin A or I want to go to origin B. That may be more difficult as you scale. So let's say you move to 3 origins, and I want to make sure I've got certain criteria for origin B in US West 2. I've got criteria for US East 1 for origin A and AP South 1 maybe for origin C. Some of the challenges are, okay, how do I maintain that geo-based routing quickly? Maybe I've got some cell-based routing that I want to determine versus cell or mobile user versus browser-based user on a desktop. Or maybe one of my origins, let's say we take out origin C, and that's actually living on-prem. Maybe that's living still in my data center I need. How do I know how to get there? The easy way that we say is CloudFront functions is going to be really, really helpful in this case because it has the ability to use something called a key value store. Now, without getting too in the weeds, a key value store is going to provide sub-second evaluation where you can store those key values, as you kind of see at the bottom, some examples to say, I'm looking for this certain aspect of the request. And if I see it, I'm going to do and run a lightweight function that checks the value in the key value store to determine what origin do I need to go to. So you can get that really, really fast, sub-millisecond, very, very low latency determination and routing based off the origin that you want the request to go to. So the advantages, kind of what we mentioned of exactly what we kind of address with the challenges, is you're going to get some of the ability to do that geo-based routing very, very quickly. So I've got certain aspects of my site I'm going to store, send it to this origin based off the geo coming in. I can look at the request pattern, and then I can determine what origin I want to go to very, very quickly. So coming back to kind of our example that Vinny gave earlier, this is kind of the same setup. The difference is this is on post request. So a key thing to think through. Vinny mentioned earlier, if you're using the ability to do CloudFront with the origin failover, it does not do post request. So let's say my application was needing to do post request. How could I have quick failover with CloudFront? CloudFront functions is going to be able to do that with that key value store we just kind of mentioned. So I'm going to play this and we can kind of walk through it. But what it's going to do is it's going to send requests to both of these distributions. Post request, you can see at the top, the URL one is using a post with a failover of Route 53. So kind of what we mentioned earlier, where it's going to take a little bit of time for it to recognize there's an issue, maybe some DNS caching on the back end, causing it to kind of stay there for a while. Eventually, it's going to fail. It's getting some 502s in return. And eventually, it'll then switch over to its other region, right? It's US West 2 in this example. What the CloudFront post failover upload with the CloudFront functions, which is a mouthful, is doing is, hey, it's going to fail over. It might take longer than what we maybe like were expecting, but it's going to be significantly faster than just typical Route 53, waiting for my DNS to catch up to what my users are experiencing. But with CloudFront functions, you had the ability for that to register and run and fail over to that other region. Now, Benny, I'm going to put you on the spot here. Why are we seeing this back and forth on the second URL? Hey, it's recovered. It's not. It's okay. It's failed. What are we seeing here?
So the way that we've implemented this this year, and it's a very common way that we can do, so we see it's kind of stable now. It's because the way we're failing over, and I can show that on the console if we have time. But the way that we've implemented this is by having a flag within the key value store, which is a simple flag, failover true or false, right? And if it's true, then the code within the function is going to take the request, change the host of the origin, and send that to the secondary. So we see this going back and forth a little bit, because while the KVS is updating and the function is actually updating, the propagation takes a little bit longer, or a couple seconds, or a few seconds, until every pop in every location is in sync with the latest information on the KVS. So that's what we're experimenting here a little bit, but still we see a dramatic difference between the two experiences. And this logic can be applied not just from a failover perspective, but from a multitude of other use cases that we can play around with the KVS. And again, I have it open
us.
here.
Let's jump in. We got 8 minutes.
If we can just, I'm just going to show that. So I'm going to go back to my CloudFront page, right? And I just want to show you what we're using to do those two URLs. So it's the same distribution that I showed you earlier. We're now talking about these two behaviors here, right? And I very simply created a behavior where I was going upload with CloudFront function and just an upload, right? I have the same origins on the back end, just dealing with a post request. What I have here attached to this specific behavior here is, if I scroll down, I have a CloudFront function. So see, it's a viewer request, because again, viewer request will be triggered at the very moment the request lands within the pop, right? When we were talking about the pops earlier. And this is my function, right? So if I show you the function, let me show you, here's the function. So when I create my function, I do the runtime, I create the basic things, and I can have a associated key value store. Now, very important, as Jonathan mentioned, CloudFront functions do not have access to call APIs, networking, and things like that. So the key value store is a local store for that function. If I open my key value store, let me click here and open that. This is everything I have here. So I have a failover enabled, set to false right now, and a secondary origin domain, which is my secondary origin, as we saw earlier on Route 53. And right now it's failover enable false. So what it's doing is, if I were to send a request here right now, the function would simply look at the request, or it would just, before it looks at the request, it just looks at the KVS, see false, okay, just keep it going, keep the request going, don't do anything. If failover KVS would be set to true, which is what happened when we recorded the demo, it simply swaps out the host header, or the host to which the CloudFront, and then sends that request back to CloudFront, so CloudFront can continue its flow. And that's all it's doing. So when we created the problem on our demo, we essentially created the problem at the origin, and we also had to kind of call the API or run the CLI command to update that flag within the KVS, so that it would tell the function, hey function, you have to failover or you have to do something, right? So that's how we implement it. This code here, we have examples on our GitHub sample AWS samples repo for origin routing and origin failover. If you guys want to have a look at that, but that's the simple setup that we have here. It's just another way, to be able to kind of route requests. We just use this as an example, so it would give you guys ideas and how to go about it.
Yeah, that's great, and that's really helpful. Just because I think sometimes, especially for me, even in the day-to-day grind of work, not seeing it in the console like this is really, really helpful to see the code and seeing how it functions. So I appreciate you showing that. Well, I know we're coming up in the last couple of minutes. Please feel free to put questions as we kind of wrap up. But when you think about what we wanted to do today, is we wanted to just make sure that you had the options available to say, if I'm thinking about going multi-region, what can I do? And we can kind of end with this, hey, a classic CDN has the ability to cache locations or cache your content at locations closer to your end users. So typically as a user comes in, they're going to hit your origin. I'm going to put a CDN in the way. And then what do I get, right? I get the ability, as Vinny said earlier, we got edge locations, or we have something that's called regional edge cache locations, which are kind of like super pops. Or we even have a function that we're not digging into today, but a little teaser. Go check out Origin Shield. So Origin Shield is an additional caching layer that requests or collapses request at the regional cache level. And then it can reduce the origin request by up to 90% from some of our sensitive applications. So some of that caching available is going to be really, really helpful when you're thinking about, hey, what are the benefits I'm getting with my multi-region application? How can I reduce the load on my back end? How can I make sure that I'm going to get the best performance available for my customers? So the key takeaways we wanted to show you today, there's a couple, like if you're thinking about multi-region, if you're thinking about starting multi-region, if you are in the midst of having conversations about a multi-region application, think through CloudFront or put it on the table. Think of it as your front door, kind of as Vinny said earlier. We want it to be your front door for your application. Regardless of what kind of application you've got, there's benefits from using CloudFront. If you want to start, always start simple. Start by maybe just thinking of, how can I do something very easy with the origin failover? How can I just create some better caching strategies for my content to reduce the load on my back end? And then as you get more comfortable, look at some of those advanced routing features, the availability options that you have for your applications. We really think that CloudFront is really helpful in this space. Again, as with anything, if you have questions, reach out to us. We're more than happy to help. Reach out to your account team. They can get you in touch with us. I'm more than happy to have those conversations if you're thinking about going multi-region or have more questions just about CloudFront. But Jamie, that's kind of it. That's where we wanted to end today. So.
Outstanding. I'm just bringing myself off of mute. Cool. So now that we have just a few minutes left, right? You guys have delivered this at reInvent, and now, if I could ask you, what is your final thought that you want the audience to take away from this discussion and from this session today? Vinny, I'll start with you. What is it that you want folks to do, and what action item would you like them to take?
I'd say similar to what Jonathan just said. CloudFront is sometimes it's forgotten. It's okay. It's just a CDN. But when we start talking to customers about all the things that it can possibly bring you, it normally changes the conversation, and customers take it more seriously on the sense of, okay, there is really a lot of stuff that we can do, all the way from availability, routing, but also from offloading your origin. Maybe there's a lot of things that we could be doing at the edge that could help you, right? Security is also top of mind, that sometimes CDNs don't get all the appraisal. So I'd say in any project, if you have a public facing application, CloudFront should be at the table at least. And the other thing is, sometimes it won't be the fit, and that's totally fine. Not knowing that was one of the things we talked about at reInvent. Not knowing when not to use it is also important. So that's also a call out I'd make.
And
yeah, I
what's
think
the action item?
oh yeah, go ahead. Sorry, Jamie.
The action item, I'd say start talking about resiliency and multi-region as soon as possible, because it's going to be a hot topic, and we are seeing that with many customers that come to us. So the sooner we have plans, the sooner we're prepared to action that type of request, the better. So that to me would be a call to action.
So Jonathan, I'm getting yelled at. I apologize.
No, you're good.
We
Let's
need to
get out of
wrap
here.
up. But hopefully you have the same thoughts as
Yes.
Vinny. And
Yeah,
thank you
+1.
everyone for joining, and we'll see you in the next one.